welcome, John, from John Elder from Elder Analytics. If you have any data science type hardcore data science problems in the US, reach out to his firm. They know it all. They have NIME expertise totally up their sleeves up to here. They can help you. And then Dean, please join me. Dean Abbott, both need no introduction. I mean, I need introduction, they don't. Dean has been on stage forever. Those are really the two gurus when it comes to data science. Welcome, Dean. You want to sit on this side? I'll sit here. We'll take John in the middle.
At very least, we can talk for a long time, so at least you've got that going for you.
There you go. And actually thinking about what just happened, maybe we'll open this up for questions here and there and just see what other topics, because the last topic that just came up about the model optimization, that may also be something where you two have an opinion. Mm-hmm. How do we get this started? Maybe, John, you didn't really have an opportunity to be here. Did you manage to catch a little piece of Phil and Simon's presentation?
Yes, I saw them. I saw Phil dressed, but I didn't see Agent Phil. I still want to see that.
Agent Phil. Okay, we'll do that next time. That's fun. So I don't know. Maybe Dean, what's your take on the framework? Does that make sense?
It makes a lot of sense because the validation of the process, that's really what he's talking about. Not so hopefully we'll talk a little bit about the data itself, but the validation of the process is something that has been thrown over the wall to ML ops or analytic ops for a long time, at least conceptually. And I will say, I talked to Phil about this. I was a big fan of analytic ops like 5, 6, maybe 8, or maybe it's 10 years by now ago, because there was clearly a big gap in the space between what DevOps could do and what we needed as a data science community. And analytic ops seemed to be fulfilling that. But in reality, it hasn't completely closed that gap. There's still big gaps there. So all the stuff that Phil described, I think, is a much more likely to succeed approach. Because it's covering the parts of the process that the IT world won't understand about the process, and the data scientists probably don't understand enough about all the underpinnings of the environment. So this is a way to bridge that gap. I see you nodding, John. Hopefully you agree.
Yeah, I do. I want to first of all disabuse the notion that I can't stand to be with Dean. Dean's awesome. I love Dean, but. Yeah, we both teach workshops, so sometimes we don't steal from one another on the workshop things. But yeah, I agree. I immediately thought back to 40 years ago when I wrote a data science algorithm. I guess it's almost that long. And a captain in the Air Force who had joined the small firm that Dean and I were part of took and used it and got some really weird results. And it turns out he had taken a numerical modeling algorithm and applied it to a bunch of text because, in his mind, it was a thing that figured out patterns and learned stuff, and here's what I want to figure out. And he just stuffed it in there. So it was like, he had managed a number of AI type programs and, was a smart fella. He just had this magical thinking about data science. And I think that's a lot of times what we encounter when we have when we're using an IT crew to keep things going. As long as it's running and not spewing out some kind of error code, they think it's working, but they don't understand the need as much.
Yeah. Yeah, I think that's a good point. Originally, when we started this like a year and a half ago, it was always, it's just CI/CD from software developments, all the same stuff. And then you realize data science is not something where you have an application that you just need to keep running and that's it. And if that crashes, you need to do something about it. But you need to actually do the monitoring, the validation, and the retraining steps. So maybe we can just get a bit more into the depth of why is that such an issue? Why, for instance, is monitoring not as easy as just saying, well, if the model quality tanks, we have to do something. Anybody can do that. What type of problems do you run into there on the monitoring side?
Do you want to start, John, or?
Yeah, just say, it's so much art as well as science. The data science depends on the data, and you have to curate that data so that it's focusing on what you want to learn. An example would be if you had a whole bunch of houses in a neighborhood. One was maybe the original farmhouse for the area or something, and it's massively different price than the other house. If you're a builder trying to figure out what will appeal to buyers, you actually want to take that data point, even though it's valid, out of the data. You want to curate the data so it's focused on the area of things you need. I think a lot of people are very hesitant to take out a real data point or something like that. So the problem is that the past is prologue to the future is when data science works, and it doesn't work when there's a big break, when there's a pandemic or a war or a depression or new laws, new tax laws, interest rates hugely different. Now, it's more robust than usual that people think, but it gets into new operating modes and it can happen very quickly and needs human judgment to know when to check things and when to see if the inputs have shifted, if the outputs are in completely different ranges, and things like that.
Yeah, and that whole idea, I think, is so critically important that a lot of business stakeholders don't really get, is that these machine learning models and these processes are looking at the past and making this very strong assumption that what happened in the past will replicate itself in the future. It's not magic. It doesn't intuit things. In fact, machine learning algorithms have no common sense like we do. They only know, all they know, this is it, the data you give it. That's their entire universe. So if the data you give it is not representative of what you will be seeing in the future, the models will fail. And then when we're talking about evaluating models and monitoring them, that's one of the things we're looking for, is when Phil described drift, when your models are deployed and you're monitoring them, seeing what they're doing, drift, which, as John mentioned, is in the eyes of the beholder. How much drift is too much drift is up to the business to determine that. But drift means that the model isn't behaving the way you would expected it to behave. And I would consider there are two primary reasons why the drift occurs. One reason it occurs is because inputs to the model, those measurable things, have drifted, have changed. So your distributions are different. The other way things drift are if the input data, maybe the distributions are the same, but the relative proportions are different. So it's like if you took the input data that produces the drifted model scores and you resampled it in such a way that you're matching the original distributions, the patterns are all the same and you'd get the same scores. But the problem is, in aggregate, the scores are different because the distributions, not of the columns, but of the rows, have changed. So there are multiple things you have to really test for and check for when you're measuring drift.
Okay, so one is really reality is changing because you're starting to see different distributions coming in. And then you see model shift when the outputs are changing, right? The prediction are changing. You're starting to see that maybe the input distribution is still the same, but the kind of what's coming out from your model is starting to change.
Yeah, that's right.
Yeah. Yesterday when we prepared a little bit, that's one I never really thought about it, is that also the monitoring goal itself might be changing, right? I think you brought that up, John, this example of saying at some point in time during flourishing economy, it's all about maximizing your profit. But then when the crisis hits, suddenly your goal changes and you're really much more interested in minimizing the loss that you're having. So you actually want to swap out almost like your monitoring goal, what you're actually optimizing, what you're aiming your model to do.
Mm-hmm.
Yes, and even though your sales might be down, you could be doing very well relative to the economy. So you have to choose the benchmark correctly.
So that's one of those instances where the IT department, nothing against the IT department, right? I mean, the people not quite having the full business understanding and the data science background need to be involved in defining the monitoring piece of when do we do something with the model. What we then do is if it automatically gets submitted for retraining or if it gets alerted to the data science team, hey, something is totally out of havoc, you need to do something, that's a different story, right? That could also go two different paths. And that's one of the workflows that Simon showed, right? I mean, you can swap that out and depending on what and this is not something where one size fits all for the company. It's really one size for every problem that you're trying to solve for almost every model.
I mean, that's a real good point because I know you mentioned financial services, but even in customer analytics, that I've worked in the past, deployed a model, we're expecting a 14% response rate to a campaign. And when it would decrease by a significant amount, which we determined, then that would be an indication that we should retrain it. But they let it run longer because there's also a monetary part of that where it was still making enough money that it didn't justify the time and the effort for the data science team to rebuild that model and spend the whatever 20 grand to do that, because it was still going to generate revenue. So there's the holistic picture of what constitutes the need to retrain. It's not just an analytics score, it's really fundamentally a business question.
Yeah. And how much resources you want to throw at it at
Yes.
what point in time, yeah, for which kind of a loss. Shall we briefly talk about that drift detection, change detection? How well does that work?
Yes, there's so many ways that things can change. And also, data scientists typically aren't as interested in monitoring or following up on things as they are in building new models. So you have to, they have to understand the business importance of it and see it as part of their responsibility, taking pride in their work to continue and budget some time for that.
Yeah, and I think drift can be calculated in a variety of ways, of course. One is just statistically, like if it's a classification model, to identify for a particular sample size what's a statistically significant change in the response rate. And when you get that drift, that change, sorry, AV people, when you get that change, then it would be time to retrain. But there's also, as we've already been alluding to, there's a business component to that they really need to be involved with it, because ultimately I'd like to make those kind of decisions in the context of the business in terms of revenue or profit or some other business metric that is more directly related to what the model's doing in practice. And so sometimes, the way I usually describe this, sometimes there are changes that are statistically significant, but they're not operationally significant. So maybe statistically speaking, for 1 million records, it changes by enough that it's great, that the p-value, and all that kind of stuff, you'd say that it's significant. But it's only generating like a 10K loss or something, so you'd say, let's just let it ride. So operationally is the more important issue.
We ran into that big time in the oil industry. We built some models to predict when gas wells were going to freeze or not produce, either due to be clogging or to low temperatures or even predictive maintenance. Maintenance shuts them down. So anything that keeps money from coming out of the ground is of concern to the oil industry, or so we thought. It turns out that if prices are really good, everything's working, so they don't need to make any changes. And if prices are bad, they cut off all spending and can't make any changes. So there's got to be some narrow price band of a barrel of oil where they'll actually do analytics and invest in it. Even though the return on investment is 100 to 1, they weren't interested in spending the 1. It was very interesting, wow. A shocker. But their business is so boom or bust that there was only a narrow band where you could get their attention.
Mm. That's almost more like about the threshold, right? You're still interested, maybe just theoretically, scientifically to detect a shift. At what point in time you then actually raise an alert or go through the trouble of retraining is then a different story. Yeah, that's very interesting. Anybody here in the room wants to throw something in? Stories from real life? There we go. Or question is also okay.
There must be a mic around here somewhere. So the question is kind of to your point, John, about the fact that data scientists are generally focused on the latest thing. They've moved on to the next project. It kind of raises a logistical issue. Who should own this, especially if the data scientist was external? Then there's even more distance between them and the model. Should it be the client IT team, maybe a ML ops team, if there is such a thing, or maybe a retainer has to be arranged to do this? So what's been your experience, both of you?
Yeah, that's a great question. In our early days, so Elder Research is in its 28th year, In our early days, we did a project, and we turned it in. We didn't even know sometimes if they implemented it or not. We were off to the next project. And so now we see that seeing it all the way through implementation is part of our job. I guess we need to see it all the way through maintenance as also. We do have a little bit easier time today because we tend to have clients that are more continuous clients, and therefore we're in regular communication to them. But we literally used to sort of drive by analytics, do the work, throw it out the window, and then hope it did well. And that's not the way to go. So, but it is something you should plan from the beginning. And I think a smart data analyst could be trained to be the first line of defense and then call in the data scientist if they are uncertain about what to do.
Yeah, and I've seen that work too, Keith, in a similar kind of way where the example I give is I used to do a lot of consulting with tax entities. I probably shouldn't state publicly, but and I would be the external consultant coming in to work with them, so I'd feel the pain of the modeling process, but they had internal people doing the modeling, and there's a lot of knowledge transfer as a part of this. But when I'd leave, they would still be monitoring the models and making sure they're working fine. Then every year or 2 years, we'd update those models. I think there's a skill set that there are different subgroups in the data science community, different skill sets. One skill set is more, I guess, like Lewis and Clark, exploring, hacking through, finding the first path to the end. And those people really like that exploration process. And I think that's kind of what you're and John were talking about. Those are the people who get bored, and they're not going to want to do the same thing over again. But there's other people who really love just being, touching with all the stuff and maybe making the second trip or the third trip. But it's a known process, and there's great comfort in having a script.
They like
follow.
mastering the process.
Yes, they like mastering the process. They like the script and keep on script on topic, and they just love doing that. Now, I wouldn't like doing that for a long time, but some people do, and that's great. We need each other, and so that's what I would try to do and I've done some of that with my company in the past to identify those people who are fitting more that style, and have them responsible for these more repetitive processes. It's not that you don't need data science skills for that. You need to understand the process. You need to understand what the models are doing and why they're doing it so that when something goes wrong, you can notice that something's going wrong. But you're not going to have to look at data in a way that's saying, oh yeah, this really is a candidate for a random forest or something based on what I'm seeing in the data. That's not the skill.
Yeah, that reminds me, I like to tell my colleagues, in order to be surprised, you have to have expectations. So you can't just take anything that comes out. You have to expect something. You have to think ahead. What do I think it's going to look like, and so forth. So I would say that a significant change requiring remodeling should be experienced as a surprise. And therefore, whoever's watching it needs to know enough to have expectations about how it's going to do.
That's a super nice analogy. It's really almost like model monitoring should be codifying the band of no surprise. And when you kind of leave that, that's the moment when whatever monitoring workflow you have essentially raises an alert or triggers retraining, stuff like that. Yeah, super interesting. Thank you, Keith. Step 2 we wanted to talk about was retraining. Seems simple, right? So if the change is not too large, I'll just trigger I throw it over the board back into the training stage, the workflow runs, spits out another model that goes straight into production, all good. What can go wrong?
What possibly could go wrong with that?
Exactly.
One of the things that struck me when we talked about yesterday, and I don't want to get too far ahead on this, but I'll dive in anyway. One of the problems I've seen in the past when I've built models, like with customer analytic models, or fraud detection can work like this too, where there's a selection process. So what the model does is it generates scores, and you get scores for all your data, and you're going to treat like the 30% subset or a 50% subset. You grab those and you do something with it. So from a tax standpoint, you send those out for audit. For customer analytics, maybe you send an email to those. But there's a problem with that, and that's when it's time to retrain those models, the modeling data that you have all the updates is a biased subset, because you've only looked at that subset along the way. You don't know what the rest of them would do, because presumably if there's model drift, one reason is the patterns are changing, and some of the people down here are now creeping up. They would have creeped up into the top set, and the ones up here with an optimized model would fall out. And so one thing I'd like to do is develop sampling strategies around the non-selects so that you include a random proportion. It doesn't have to be huge because you don't need that many examples, but you need some examples from the non-selects to populate your data to when it's time to update. You've got some examples that are in the non-selects that will help your model tune itself better. So it's, I have to say, John, we're joking about this yesterday because I don't think I've ever seen that written up anywhere. But I think a lot of data scientists I speak to incorporate this practice because it's obvious if you've lived through it and it's obvious when you've made the mistakes and you've seen how bad the biased models turn out being. That you're like, oh, and you can only collect data once. It's like selling your furniture. You can only sell the stuff you're getting rid of your house once and then it's gone. You can't do it again. And so with data, you can only collect it once. If you don't collect it, you never have it. So I always like to collect it when I can.
Yeah, you need to do some kind of at least random audits, and those are expensive and hard to sell up to management and things like that. But you have those false dismissals where there was something down there and you didn't catch it, and you have no idea what the rate is because you've done no work, and so you have to reserve some of your work for that. And there's also another way, and that's tips. Analytics is a way to do automated tips, but anyone fighting fraud or waste and abuse always relied on a hotline before, and didn't have any automatic way to uncover it themselves, but they would wait till some disgruntled, employee of somebody who's cheating the company reveals it. So that can be a way that new information comes in, and then you can try to look for other cases like that and follow. When we did some anti-fraud tax work, and by the way, the work that Dean and I have mostly done is against organized crime, not against individuals. It was very useful to look at graphs of the interrelationships, and then you could get to sort of the hubs, maybe the criminal preparers that were doing the filling out the forms and inventing people and things like that. So it really improved and also for fraud like breakout fraud with banks, it's where conspirators get together and create a bunch of fake accounts, and none of the accounts ever break any of the rules of the bank. They transact, but they only transact with each other. So you have sort of this cancerous tumor, that's pulsating, and all of a sudden, one day, all the accounts leave after they've gotten loans and credit cards and things like that. They break out. So you can only look at it by looking at the links between accounts rather than any stats of an individual account. So I don't know if there's an analogy there for monitoring or not, but it's.
I'll give you one. One of the analogies, like John was describing, is that with fraud in particular, the problem with fraud is if your models are successful, they will necessarily drift. Because if you're closing down those avenues, then the fraudsters, being clever as they are going to find new avenues. So your models have to continually chase the new ways to defraud the organization. And so you always have to monitor to maintain it. And I see if I could jump to this question, which ties into what I was going to say about it. There's a question on the screen when you mention updating the model. Is this just current data or an actual bottom-up reassessment of the variables? And I think it has to include a more comprehensive rebuild if the model drift is significant. I mean, sometimes I'll just freshen up models because I just like to keep them new and fresh, and I can do the same process, and that's fine. But if there's drift, you need to do a reassessment. And one of the key reassessments, I'm going to dive into AutoML for a moment, Michael.
Go for it.
Which I know I think Phil talked about AutoML a little bit. But one part that's missing from the AutoML frameworks I've seen is automatic interaction detection of your input variables. Because many times when I've seen the drift occur, it's because there's a new interaction effect that we didn't know before or we hadn't seen before, and now it's emerging. And to do that automatically as a part of the model building process and then the model updating process is something that I really promote and like to do myself, because those interactions, that's where the gold is. Most often, the main effects, the individual variables, can be powerful, but the biggest value that I get almost always is with identifying interaction effects. I don't know if you agree or disagree, John. Just
I always agree. Always agree with you, Dean.
no, we can raise
This is
the points
supposed to
we
be more
disagree
of
on too, so we can.
I don't know.
No, John and I are like 95% in agreement on all this stuff. So
Okay, let's see if we can find something where we disagree. Anything from okay? So retraining isn't as trivial either. Damn it. So it does make sense to open up that box from time to time and actually go in. What does it actually mean? What do we do when my customized monitoring workflow triggers a retraining? Obviously, I need some idea of what that actually means. Is it just refreshing the model, like you mentioned? What kind of data am I going to use for the refreshing the model? Or is it really full-blown retraining of everything? Any other comments, questions from the audience here?
I have something while folks are thinking about it. I'll just give an example that might spark some conversation. We work for a packaged goods company that's worldwide, and during the pandemic, they were selling a lot of stuff that people needed. For example, toilet paper. So, and there was runs on toilet paper. It sounds terrible, but there were, reduced supplies of toilet paper everywhere, and you would see dozens of articles being written about hoarding. People are hoarding, and certainly there were some, but if it was true hoarding, the supply bubble would have vanished and things would have caught up. And it was months and months and months before folks kind of publicly knew what was going on, and it's that the product is completely different in public spaces like, offices and libraries and train stations and so forth than it is in the home, and the hardware that creates the packages couldn't be easily retrofitted to make one for the other. So there was a surplus of, if you will, commercial toilet paper and a dearth of everyone was spending so much more time at home that the demand was like double or triple of what it would normally be. And they couldn't easily meet the supply even months and months later, even though it was enormously profitable to do it. So this is really a situation where data science wouldn't have helped you. You had to have folks figure it out and try to figure out, ways around it. So as much as I love data science, there are anomalies, and unless there's much later, you might have more data and you might have some hope, but for months, you'd have to rely on gasp intuition and creativity.
No, that's actually very good. And you missed the earlier parts of today's session. We had actually someone from Procter & Gamble on stage who was talking about toilet paper. Yeah. And I'd like to point out that at the 9 offices, we only have wonderful, very soft toilet paper, so people feel at home there. Just making sure. But that's a super interesting example, right? That's one of these cases where you do want to go back to your data science team and just say, hey, retraining, this is something, it's outside of this, it's too surprising to warrant retraining. Let's throw that back to the data science team and figure out what the hell happened and see what the root cause of that surprise is. Interesting. Okay, so we are retraining models and we are optimizing the hell out of variables, and we'll just throw this back into production. What could go wrong there? When Phil and Simon were talking about validation, right? We were mostly talking about technical validations. Are credentials embedded? Is it using evil scripts? It's more like technical stuff. Does that fulfill technical compliance? But there's probably more to it that you want to do on the validation side, right?
I'm weighing whether I should respond to something John said, because that was really. If I could just back up just a little bit,
you can.
Michael, what you're saying was really interesting, John, about the data science not being able to solve these kinds of problems because there's not history. And really what drives the amount of history you need is, as John is a double E, and I minored in double E. I was never a proper electrical engineer. But
You tell me now?
is from a frequency standpoint, it's the shame, is how quickly the patterns emerge. It's at a low frequency or a high frequency. So essentially what is the Nyquist frequency of what the model is trying to capture? So if you have something like you were describing, John, with the toilet paper things, if you really need 2 months of data to really track enough information so that you could forecast what's happening in the future very well, then yes, you're going to need 2 months of data before you can get there. If it can happen more quickly, then you could forecast better. And this is when I was building models for, I think I can say, I was building models for the Navy SEALs to identify who would make it through Hell Week. And one of the questions, we landed on that as the target variable, not because that's really what they wanted. What they wanted was a successful SEAL. But you only find out if someone's going to be successful after they've gone through training, they've been deployed, blah, blah, and it's years. The problem is years out, that kind of a low frequency play out of the patterns takes too long. Because then by the time you're ready to rebuild, the data that you had about what they look like when they came into the system, which is all the data you have to build your model, it's 3 years old. The same thing is true with tax modeling, because you've got compliance problems. You can't go, tax laws change every year, and you can't, even though in 3 years, it takes 3 years for everything to work through the legal system and know if the audit was successful or not, that's too long. You've got to update your models quickly, at least annually, in order to capture the patterns. So you have to deal with the patterns that you have after that shorter period of time. So the way the patterns play out, I'm looking at you again, John, but the way the patterns play out over time is a critical part of the model maintenance process, how quickly you need to update the models, and also the model building process, how much latency, how much delay you can have between your input state and the target variable. The same thing plays out with churn models and how much of a look ahead you need. There are all kinds of modeling problems that have a temporal component with the target variable you're trying to predict that you really have to think through from a business perspective.
But you're cheating. That has nothing to do with monitoring, retraining, or validating.
But it is the
That's just a
retraining
data
part.
science problem.
It is retraining because the retraining to know when you can retrain, does the temporal part plays into that decision.
Okay, so that's a data science problem that makes retraining even more complicated.
Yes,
okay,
that's right.
Good. Okay, fine. I'll give you that.
I finally could tie it back to that.
Close though. Okay, we have a few minutes left. I do want to talk briefly about the validation issue because, I mean, there are also the easy answers, right? Yeah, I mean, okay, we do all the technical tests. Now we have a golden standard table of our 10,000 best customers. We make sure before we deploy the model that the classifications or whatever we're doing on that golden table are reasonably accurate. Go. And then the model runs. What's wrong with that?
John, do you want to dive on that first?
I tell you, it sounds a lot better than what is done most of the time.
I know, that's the thing. That's actually pretty good. But one of the problems, the validating a model, there are different parts of the validation. Part of it, is, as Phil was describing, is just the process, which,
right.
And that's relatively straightforward. From a numerical standpoint, what is considered good, a prediction is good, of course it always has to tie back, it always should tie back to the business question you're trying to address. So when you're validating a model, is there drift? Is this doing what it should do? It should be described in the terms of the business. But one thing that always disturbs me about models that are pushed out to the field is the predictions themselves, because if you think about it, you've got all this data going through your model and you get a single number out, which is the score that you're making decisions on. Mm-hmm. And one of the questions that disturbs me about that is, how sure are you that that is the real number? Really what we want, well, with some statistics, and John has a lot more statistics than I do. I had to back my way into it. But it's not just, it's a point estimate. It's that plus or minus something. How sure are you that that prediction is really the reasonable prediction? Because in the end, when you're trying to decide, and when you're validating your models, you're trying to decide what predictions to put out to the field, whether it's auditing a tax return or something like that. It's not just how likely is this tax return going to yield something positive for the entity, like the IRS or Revenue Canada or the state. It's, is it worth the time of the auditor to chase it? Because if it's that value, that's, if I had to make a guess, it's going to be a $10,000 audit back to the tax, the government agency. But it's really 10,000 plus or minus 8,000. And if it's really 10,000 plus or minus 8,000, I don't know, that's kind of a coin flip, whether it's worth chasing, because you don't want someone to put $20,000 into an audit that you're only going to get $10,000 out of. So it's, or even $10,000 into an audit or $8,000 into an audit when it could only be a $2,000 audit. So if you could measure how sure you the predictions are those predictions, that would be very helpful in validating those particular model scores.
And that's why I was asking the question. So model stability, prediction stability, that type of stuff is Dean's newest hobby? Is that the
It's
right
one of my
word?
newest hobbies. This started like 20 years ago. I was doing a talk at the UCSD Supercomputer Center. And so all these really smart big data guys were there. And I was talking about ensembles. Maybe it was 15 years ago. Talking about ensembles and how cool they were. And then some wise guy said, yeah, but how do you know that that's a good prediction or not? What would you do?
Yeah.
And I was thinking about it. I said, well, what I would do is I'd bootstrap sample the data and build models in those bootstrap samples so that I get a distribution of scores for that individual record. And then that would give me kind of the confidence intervals associated with that. And he nodded his head. He said, okay, that's a good answer. I'm okay with that. So, but I never did anything with it for like 10 years because I didn't have time to look into that until I started doing the Power of Random course here. I was thinking now it's time to really take a look at that and apply it to my some clients of mine.
Okay,
And
so we're looking forward for the validation stability of models component for the community hub so that people can use that in the CDDS
and I'm going to send
framework.
those NIME, I've got a NIME workflow that does that I'm going to send to some folks with NIME to
Sounds good.
take a look at it.
Well, Michael, if I could
Yes,
put a
please.
pet idea in your excellent software, I'm kind of obsessed with training data that has errors in it. And if you use modeling techniques, it's always valuable to look at where the model had the hardest time fitting the data, and to maybe re-examine that data. There have only been a couple of times when we've been able to do this at scale, and the results have been fascinating. One time a prediction that actually a client was eager not to use the model and focused on the 200 predictions that our model had said were class A and they thought it wasn't. And then they were going to prove it wasn't, so they went back and sort of audited and investigated. They ended up finding that the model was right 75% of the time. So where the model and the data disagreed, even the training data, the model was right because most of the time because it had picked up it had learned from the rest of the data. And then they flipped it to the other side and looked at the most extreme ones on the other side, and it wasn't that dramatic, but they also realized that they were able to make a better determination on those cases because of a third data set that they had provided to us. So they came back and said, hey, could you do some more work, which we always say yes to, of course, with this third data set, and they were enormously positive about the models after they had done that work. So I've been in lots of cases where you see a case maybe on a medical problem where there's a lot of cancer, and then there's a case that's labeled not cancer, that's completely in that cluster, and you just know that was misidentified. So it would be very valuable on your monitoring software and so forth if there's any feedback from cases that you eventually learn about and you find out which ones were, most surprising, because there's a lot to be learned there, either on training the people who are there's a lot of outputs that are labeled by human judges and not physics. When physics labels it, there's not an error, but when a human labels it, like a doctor, I'm told, looking at a radiologist looking at a sheet, and trying to get the determination, if they look at the exact same chart the same day later, 20% of the time, they have a different diagnosis. So there's just a lot of error in anything that involves a human expert, and that may be the best answer you can get, but this feedback from the modeling stage can be enormously valuable to both improve the human and the computer.
That's a really good idea, that the approach you're describing, John. I really like it a lot because where models are wrong, I'm usually not as bothered about models making high confidence, like in the top decile when models are wrong. Like why, the first question, why are the models wrong? Like why are they misclassifying? It's because the exact same pattern is associated with the ones as associated with the zeros. You know, and so because of that, it's either a labeling problem or what we usually assume is it's insufficient data that this is the best we can do. But that's not always the case. Sometimes it is just mislabeled. And so to me, especially when it's not life-threatening, like you're talking about really life-threatening things, but when you're doing customer analytics and stuff, I mean, you're not curing cancer, it's just whether you send someone an email or something. That, to me, that screams opportunity because yes, they didn't respond, but they look just like the responders. So, therefore, they're still a good candidate for doing something with, even if the model's wrong with them. So it's interesting. I think in the principle that you're describing, John, which is really good, is don't just take the scores and call it a day. Understand why the scores are the way they are. Try to understand those patterns, those characteristics, those input variables that are generating these kinds of errors, and try to understand something more about the process, because then you can get insights just like you were finding.
Yeah, and you may learn more about the process by examining the hardest cases.
Yes. Yeah.
Okay. So one of the things I hate about these types of panels is that you have to stop them when they're getting really good. And we're already a little bit over time. So we'll just stop sharp here. You can continue talking with Dean tonight over a beer at Smash. Unfortunately, John, you can't be here, but next year we'll have you on stage, we'll have you around. And we can maybe continue that discussion or pick a new fight. It wasn't really a fight, though. Thanks a lot, John. Very much appreciated
Thank you.
dialing in.
Great.
Thank you.
Wish
High
I
five,
could be
John.
there.
Thank you, Dean.